Afternoon, Miss Trisia.
Good afternoon, ma'am.
Hi.
Hello, ma'am.
Yes, are you the moderator for today?
Yes, ma'am. Yes, ma'am.
All right. All right. So now you are already set as co-host. I think you can unmute yourself.
Thank you.
Okay. And do you have today's speaker's CV already?
Yes, ma'am.
All right.
Dr. Rhoda gave it to me.
All right. So today we have two speakers for Pak Febrian and also Dr. Richard. Yeah, is that right?
The
other
speakers that
okay.
I think it's Dr. Eusebio, Mique.
All right. So is he here already? From Dimsu?
Hello, Dr. Mega.
Hello, Dr. Roda.
Good afternoon.
How are you?
Sorry, I cannot turn on my camera because, yeah. Dr. Mega, the updated flyer,
Okay.
the updated flyer.
Flyer.
Again?
Okay.
For
send me, please.
Yes, for this session, it would be Dr. Mique, and then tomorrow's session, it would be Dr. Marsan.
I see.
Yes.
I see.
Yes, Dr. Mega.
Eusebio, Mique.
Yes, Dr. Mega. They were informed already, and Dr. Mique knows that his turn will be on the second session.
Hello, good afternoon.
Yeah, good afternoon. It's very nice to meet you here.
Same here.
Yeah, Natasha, please set Dr. Mique as co-host because he will share his PowerPoint. So I think he needs access as co-host. Natasha, can you hear me? Natasha.
Yes, ma'am. Yes, ma'am.
Okay. Dr. Mique ya, namanya Dr. Eusebio L. Mique TR. Okay. Pak Anto belum masuk. Bentar. Natasha, absensi hari ini udah ready?
Sudah.
Dikirim ya.
Oke.
Anto udah join ya?
Sudah dengar enggak Bu suaranya?
Ya kedengaran. Pak, hari ini kita ngerahkan mahasiswanya Pak Anto berarti? Udah perintahkan belum?
Ya,
Ya, kasih.
Jimsu at a glance. Don Mariano Marcos Memorial State University, or DIMSU, is the lone state university in La Union, Philippines. DIMSU was created through Presidential Decree 1778 on January 15, 1981 by former President Ferdinand E. Marcos. Founded on the philosophy, total human development, DIMSU was born from the merging of 5 former schools of La Union, namely Don Mariano Marcos Memorial State College at Bacnotan, La Union, La Union School of Arts and Trade at City of San Fernando, La Union, Community College of La Union at City of San Fernando, La Union, Southern Ilocos Polytechnic State College at Agoo, La Union, and Sapilang Elementary School at Bacnotan, La Union. The university has 3 major campuses, namely the North La Union Campus in Bacnotan, the Mid La Union Campus in San Fernando City, and the South La Union Campus, which is sprawled in the towns of Agoo, Santo Tomas, and Rosario, La Union. DIMSU also houses the Open University System, which is located in San Fernando City, La Union. DIMSU is the home of 2 national centers, the National Apiculture Research, Training and Development Institute, or NARTDI, and the Sericulture Research and Development Institute, or SRDI, anchored in 7 core values, namely service, productivity, excellence, commitment, innovativeness, advocacy, and leadership. DIMSU envisions to become a globally competitive university and is empowered to provide high-quality instruction, research, and extension. Its undiminished goal is to lead in transforming human resources into productive, self-reliant citizens and responsible leaders. Living with its mantra, embracing world-class standards, DIMSU is ISO certified. Through the strong leadership of the current president, Dr. Jaime E. Pacmanuel Jr., and the vice presidents, and the teamwork and commitment of all DIMSU personnel, DIMSU passed ISO 9001-2015 on November 19, 2020. The audit scope includes the provision of instruction 9001-2015 Certificate number 20.67.PH112906.00, originally approved on November 19, 2020, was issued on November 29, 2020. Further, on November 8 to 12, 2021, DIMSU passed the first surveillance audit and the certificate attesting that the university QMS conforms to the requirements of ISO 9001-2015, number 20.67.PH112906.01, was issued on November 29, 2021. As an affirmation of DIMSU's excellent systems in rewards and recognition, learning and development, and recruitment, selection, and performance management, the Philippine Civil Service Commission, or CSC, conferred DIMSU with certificates of recognition. These implies that the 3 systems have reached maturity level 2. Also, DIMSU's North La Union campus passed the Institutional Sustainability Assessment by the Commission on Higher Education. DIMSU has 109 academic programs broken down into 13 doctorate degree programs, 31 master's degree programs, 58 baccalaureate degree programs, and 7 diploma or certificate programs. In addition, the university boasts of 20 academic programs that have been re-accredited to Level 4 status by the Accrediting Agency of Chartered Colleges and Universities of the Philippines, or AACCUP. These programs are BS Agroforestry, Bachelor of Elementary Education, BS Agribusiness Management, BS in Environmental Science, BS in Information Systems, PhD in Technological Education Management, MA in Technology Education, PhD in Development Administration, MDA Majors in Business Administration and Public Administration, BS Industrial Technology, BS in Hospitality Management, BS in Business Administration, PhD Science Education, MA in Science Education, MA in Mathematics Education, MA in Teaching Music, MA in Guidance and Counseling, BS Mathematics, BS Biology, BS Computer Science. Likewise, 18 programs are Level 3 re-accredited, 15 are Level 2 re-accredited, and 22 are Level 1 accredited. New program offerings have also been subjected to preliminary survey visit for the assessment of their readiness for accreditation. Because of DIMSU's rigorous engagement in accreditation endeavors, DIMSU was recognized by AACC-UP as top 1 in the highest number of Level 4 accredited programs in 2020, top 2 in the highest number of Level 3 accredited programs in 2020, top 3 in the highest number of Level 4 accredited programs in 2019, and top 3 in the highest number of Level 1 accredited programs in 2021. Moreover, the colleges of Education, Information Technology, and Computer Science are recognized by the Commission on Higher Education as centers of development. DIMSU implements strong programs for faculty, staff, and student development. It initiates numerous trainings to upskill and cross-skill, and to equip and empower its 577 faculty members and 514 non-teaching personnel. To provide a quality environment and to ensure quality processes, DIMSU continues to build state-of-the-art infrastructure projects equipped with cutting-edge tools, equipment, and machineries. In fact, DIMSU is already gearing towards becoming a smart university. As a result of quality curriculum, quality processes, and quality academic environment, DIMSU has been producing quality graduates who are among the most preferred graduates in the Philippines and abroad. What's more, DIMSU maintains excellent performances in various licensure examinations. In fact, DIMSU ratings in licensure examinations are much higher than that of the national passing rates. For the past several years, DIMSU has produced top-notchers in national board examinations in the fields of mechanical engineering, electrical engineering, agriculture, fisheries, agricultural engineering, veterinary medicine, forestry, teacher education, psychology, guidance and counseling, midwifery, and master electrician. What's more, as surveyed by the Commission on Higher Education in 2001, DIMSU ranked among the top 10 higher education institutions in the Philippines and 7th among the more than 1,000 private and public colleges and universities in the Philippines. Areas evaluated were faculty, student admission, library, academic offerings, research and extension. DIMSU was also listed in the CHED 2011 to 2016 Roadmap for Public Higher Education Reform as one of the 19 leading state universities and colleges in the Philippines. As for research, DIMSU's research program is one of the biggest programs in Northern Luzon in terms of the number of ongoing research undertaken and budget allocation. Its research commodities include fiber crops, fruit crops, beef and chevin, pork, orchids, bamboo, agroforestry, poultry, agricultural engineering, farming system, applied rural sociology, macroeconomics, purple yam, bananas, sericulture, and apiculture. In fact, DIMSU has recently been named by DOST PCAARRD as top intellectual property filer. Meanwhile, extension programs of the university are anchored in commodity-based services that create an impact on the life of the clientele in terms of productivity, profitability, and services for the enhancement of local government and non-government organizations. DIMSU Techno Pinoy, also known as Farmers Information and Technology Services or FITS, has been named by the Philippine Council for Agriculture, Aquatic, and Natural Resources Research and Development as one of the country's active and functional centers. Kapihan sa DIMSU, an extension program which is aired online, has also been reaching thousands of clientele. Acknowledged for its distinct competence, expertise, and resources, DIMSU is home to a number of special projects. These include the Sericulture Research and Development Institute, or SRDI, the National Apiculture Research, Training and Development Institute, or NARTDI, Fisheries Research and Training Institute, or FRTI, Jimsu Pig Extension and Research Farm, or DPERF, and the Philippine Carabao Center, or PCC. The Affiliated Non-Conventional Energy Center, the Metal Crafts and Innovation Center, and the Agri-Aqua Technology Incubation Center. At present, the university is sprawled on a 1,120-hectare land area, cozily splintered in 7 major units. The Central Administration, the National Apiculture Research, Training and Development Institute, the Sericulture Research and Development Institute, the North La Union Campus, the Mid La Union Campus, the South La Union Campus, and the Open University System. True to its goal of transforming human resources into productive, self-reliant citizens and responsible leaders, Jimsu takes pride in its commitment in fulfilling its vital role in the country's national development.
PGRI Semarang is located in culturally strong Semarang City, Central Java Province, Indonesia. With these features, Semarang is a potential place for students to develop themselves. The spirit that drives Universitas PGRI Semarang is nationalism and religiosity. Nationalism is the spirit to unite the nation in the midst of culture differences. We have 7 faculties consist of Faculty of Education. This faculty is the oldest faculty at our campus with the largest number of students. It has 3 study programs: the Guidance and Counseling Study Program, Elementary School Teacher Education, and Early Childhood Development Teacher Education. Faculty of Social Science and Sports Education. There are several points that become our focus in this faculty. First, the value of humanism as national identity. Second, physical health as a support for quality education. Third, the understanding of economic values as a pillar of human civilization. This faculty has 3 study programs: Pancasila and Citizenship Civil Education, Physical and Recreational Education, and Economic Education. Faculty of Language and Arts. This faculty provides education to generate language and art educators with pedagogical personnel, social and professional competence and competitive abilities in dealing with the current age development in order to develop themselves into professionals such as translator, newscasters, or journalists by making use of their language and artistic skills. This faculty has 3 study programs: Indonesian Language and Literature Education, English Education, Regional Language and Literature Education, Javanese Language. Faculty of Mathematics, Science, and Information Technology Education. This faculty has study programs of Mathematics Education, Biology Education, Physics Education, and Information Technology Education. The vision of this faculty is to be an excellent and distinguished faculty of mathematics, natural science, and Information Technology Education by 2025. Faculty of Engineering and Informatics, established on April 17, 2014. This faculty has 6 study programs, namely Architecture, Mechanical Engineering, Civil Engineering, Electrical Engineering, Informatics, and Food Technology. Faculty of Economic and Business. This faculty has a mission to be a faculty of economics and business that excels in the field of digital-based, creative economics and business with a distinctive identity. Faculty of Law. The Faculty of Law of University of PGRI Semarang is committed to develop legal knowledge, and this is done, among others, by organizing seminars, discussions, comparative studies, and field experience practices. In order to support the teaching and learning activities, we have 4 complexes of campuses. Campus 1, located at Jalan Dr. Cipto, Jalan Lontar. This campus consists of representative and modern buildings for teaching and learning activities. This campus consists of central building, main building, student activity center, library, graduate program building, as well as a representative auditorium meeting hall for national class concerts and international seminars. Campus 2, located at Jalan Sriwijaya. This campus has a hotel available for both students and public in general, as well as a large meeting room for teacher professional training programs and various other large-scale meetings. Campus 3, located at Jalan Bendan Duo. This campus has a building for students' practices, especially mechanical and electrical engineering department students. This campus supports various activities to increase electrical, mechanical, and architecture skills. Campus 4, located at Jalan Gajah. This campus has a teaching learning building complex and sports centers including basketball, badminton, futsal, and other athletic sports activities. This campus also has a dormitory building provided for students, as well as a high school laboratory school, which was established by the Universitas PGRI Semarang. Why do you have to choose UGRIS as a place to study? We realize the importance of international relation to connect the discourse currently developing in the international world. This is where we establish a collaboration to open up opportunities for career later through students and lecture exchanges, credit transfer and double degree program, joint internship and research, and publication with our reputable university partners. We believe that in our fast-paced and competitive world, there are basic competencies every young generation has to possess, namely excellence and distinction. Excellence in either emotional and spiritual intelligence and the ability to retain the personality as a cultured human being. Please join UGRIS.
Okay, so hello, good afternoon, everyone. I would like to greet our participants, especially our dear speakers for today's program. We have Professor Febrian Murti Dewanto and Dr. Eusebio Mique Jr. And I think we also have with us today Dr. Roda M. Lilan, the head of the Internationalization and Linkages of DIMSU, and also Dr. Megan Novita, the head of the internationalization of UGRIS, who is also here to join us. And of course, to our colleagues and students from Universitas PGRI Semarang and Don Mariano Marcos Memorial State University. Good afternoon, everyone. It is a pleasure to have you all here today. My name is Christian Ramirez, and I'm from DIMSU. and I will be your moderator for today's webinar session 3. Okay, but before we start, let us begin with a prayer and singing of the national anthem of the Philippines and Indonesia.
All that I am, all that I have, I lay them down before you, oh Lord. All my regrets and all my acclaims, the joy and the pain, I'm making them yours. Lord, I offer my life to you. Everything I've been through, use it for your glory. Lord, I offer my days to you, lifting my praise to you as a pleasing sacrifice. Lord, I offer you my life. Things in the past, things yet unseen, wishes and dreams that are yet to come true. All of my heart and all of my praise, my heart and my hands are lifted to you. Lord, I offer my life to you. Everything I've been through, use it for your glory. Lord, I offer my days to you, breathing my praise to you as a pleasing sacrifice. Lord, I offer you my life. What can we give that you have not given? What do we have that is not already yours? All we possess that is not worth living, and that's what we give to you, Lord. Lord, I offer my life to you. Everything I've been through, use it for your glory. Lord, I offer my days to you, lifting my praise to you as a pleasing sacrifice. Lord, I offer you my life. Lord, I offer you my life.
semangat pengabdian untuk bangsa dan tanah air. Jadilah sarjana, jadilah cendekia, jutaan rakyat menanti. Ulurkan tanganmu, selamatkan bangsamu, berpedoman Pancasila. Universitas PGRI, tempat kami tempat, alma matermu tercinta. Ku kenang jasamu selalu padaku, ku berjanji wujudkan karya nyata. Ku doakan pada Tuhan yang kuasa, Universitas PGRI tetap jaya.
Ang pambansang awit ng Pilipinas.
Alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyak ka ng magiting. Sa manlulupi, di ka pasisingil. Sa dagat at bundok, sa simoy at sa langit mong bakaw. May nilang ang tula at awit sa paglayang minamahal. Ang kisap ng wataw at mo'y tagumpay na nagtitindig. Ang bituin at araw niya kailan pa may magdidilig. Lupa ng araw ng waro aming pagsikta, ay langit sa likod. Aming ligaya na pag may mga aking at mamatay ng dahil sa'yo.
Okay, so again, I would like to welcome everyone to the third session of the lecture series in computing disciplines. So today we have two exciting topics that will be discussed by our esteemed speakers. But before we proceed, I would like to remind everyone to observe proper webinar etiquette. Please keep your microphones muted throughout the session so that all participants could hear the speakers while they are giving their lecture. And in order to avoid any background noise that may distract others. Also, if you have any questions while the talk is ongoing, you may just type them in the chat box that we have, and we will just read them and address them during the question and answer portion. And lastly, let us all respect one another's opinions and avoid any disrespectful behavior, most especially while the talk is ongoing. Okay, so now I think, okay, so now without further ado, let me introduce to you our first speaker. Today we have the pleasure of hearing from Professor Febrian Murti Dewanto, a distinguished lecturer in the informatics department of the Faculty of Engineering and Informatics at the Universitas of PGRI, Semarang. Mr. Dewanto has an extensive background in the field of education, having served as Vice Dean and Head of the Informatics Department at UPGRIS, as well as a secretary of various education departments and technical implementation units. He also served as a secretary of the Computer Center Technical Implementation Unit and secretary of Information Technology Education Department at UPGRIS. He also holds a Bachelor of Economics in Management from the University Diponegoro, Semarang, and a Master's in Informatics from the University Dewanto, Semarang. Today, Mr. Dewanto will be sharing his insights on sexuality education in early childhood through animation series and mobile application. So let us all welcome Professor Febrian Murti Dewanto, our first speaker today. Sir?
Yeah, thank you. Thank you, Dr.
Hello, sir. Good afternoon.
Good afternoon. Can you hear my voice?
Yes, sir.
Okay, good afternoon, everybody. Thank you, Dr. Krisa and Ramirez, and thank you for having me in this series, lecture series in computing discipline. Thank you for Dr. Eusebio and our next lecture presenter and all the participants for having me in this session. So today I will present about in our computing discipline that about sexuality education in early childhood through animation series and mobile application. Let me share my screen. Okay, wait a minute. Okay, can you see my screen?
Yes, sir. Yes, sir.
Okay. Okay. Today I will present about lecture about sexuality education in early childhood through animation series and mobile application. Before I start, let me introduce myself. My name is not yet a professor. I'm a Febrian Murti Dewanto. My name is Febrian Murti Dewanto. Usually call me Mr. Anto in Indonesia, in Semarang. Yes, I'm a first team 2 in informatic Faculty of Engineering and Informatics, and now I'm lecturer in Informatic Department, Universitas PGRI Semarang, or also we call it UPGRIS. And if you want to know me better, in email, febrianmd@upgris.ac.id, and then my research, there's in Google Scholar too, in Scopus, Web of Science research. Also, I have a YouTube channel. Maybe you can visit, subscribe, maybe about tutorial in computing discipline, because I in informatic department I teach many subjects such as basic programming and web programming, object-oriented programming, and then animation too, and interactive multimedia. So I was a lecturer from 2010, and now almost 13 years in UPGRIS Semarang. Okay. Today our lecture, our presentation about sexuality education, of course, from our research. Our research partner, Mrs. Desi Maulia, Master of Psychology, and Dr. Dini Rahmawati. They are my research partner because their background is from counseling department, Faculty of Education. So the subject of research, they know well about the counseling and about childhood and everything. And of course, my part in this research about the informatic discipline, and then research and development of product about this sexuality education for early childhood. Okay. This research start in 2019. We get research grant from our government, and for 3 years, and we start readiness level 7. It means it takes 3 years to become a product that is needed by community. Our product then can dissemination in our community to 2019, 2020, and 2021. In 2019, we got a three stages. First stage, we done a need analysis. There's a pre-survey, preliminary study of previous research, and then field survey to obtain demographic information of the city Semarang. Of course, this scope of this research in Semarang city of Indonesia, and activities of the quality education in early childhood education, and then examine the result and studies related to the child sexual violence prevention program, and summarize the problem. And then the second stage will be the planning about information accumulation, formulating goals, and then determining steps and expert judgment on a small scale. And then in the third stage, initial product design. At this stage, the researcher will design the animation series program for sexuality education as a prevention of sexual violence in early childhood. Yes, first year, we got a third stage. We got 3 stages that from mid analysis, and then planning, and then the initial product design. In 2020, we have done 4 stages, early stage trial on small sample. The assessment was carried out using several techniques of analysis. And then the 5th stage about product revision. These activities of this stage include validation from expert through focus group discussion, and then product revision based on expert input. And then the expert involved include health worker, counselor, expert of childhood, early childhood, and expert from sexual violence prevention expert, and IT expert, especially on animation. And then in the 6th stage, we do a trial of the animation series on sexuality education as prevention of sexual violence in early childhood. At this stage, the program is tested in the larger group by providing the instrument of as a measuring tool. And then the 7th stage for this year, we have done a product revision using input from field trial and focus group discussion from expert. And the last year, 2021, we also done 3 stages that the 8th stage will be with field testing. The animation series was applied to a larger group and analyzed, and then the 9th stage revision of the animation series, and then the 10th stage of the result dissemination. There's 10 stages from our research, 3 years research about sexual education for early childhood. Okay, let me start with need analysis that why our research about this theme, this topic, because in Indonesia we have 270 million people. The population, that 30.38%, 30.38 million is early childhood. Early childhood is an coaching effort that addresses to children from birth to the age of 6 years, 0 until 6 years old. This can be done through the provision of education stimuli to help growth and physical and spiritual development of children in order to have readiness to enter the further education. The education for 0 until 6 years old is called the early childhood education. Or in Indonesia, we call it pendidikan anak usia dini. We abbreviated with PAUD. The percentage of early childhood children who have been crime victims and reporting to status to the police. Background for this topic. 0.03% for early childhood have been crime victim. This crime include that theft, assault, theft with violence, sexual harassment, and other, such as kidnapping, extortion, fraud, destitute, and so on. So only 25.15% reporting the status, the crime, the victim crime, reporting to the police, only 25.15%, and not reporting to the police, 75.85%. 0.03% from 30 million population in Indonesia, and maybe 9,114. Of course, we study the case from years to years. From 2019, there's 2,807 cases. 2020, 1,153 cases, and 2021, 1,149 cases. And then our first survey done for parents that owning four until 6 years old children in Semarang, especially in our city, in Semarang city, and it took about 196 people as the sample all over the Semarang, and then with the descriptive analysis, and the result, this internet mapping, so about 14% using this internet for amusement, 37% to amuse and educate children, and 48% to enrich religiosity and characteristic knowledge, and only 1% use it as a means of sexual education for early childhood. So there's only 1% in the internet that content about education, sexual education for early children. The solution, we try this research. Before we product something, we need to analyze and then trial about this product. We need an interactive media to help to educate about sexual education for early childhood. Of course, our users in this interactive educational media are the children itself, and then the parents and the teacher. Okay, this is a product that initial product design that have been great. We have six video, but educate about sexual for early childhood. The video series number 1, the title is Me and My Body, and then number 2 is Safe Thoughts. Number 3 is Change Clothes, and video number 4 tell about the family and people around me, and then video number 5 is about respect yourself and other, and number 6 there's when there is a danger, what have to do. So if there's strangers coming, and what to do. This is the 6th animated series we created. We create in 2-dimensional animation, and we use the software of Animate, Adobe, and the duration is about 1 minute or 2 minutes long. Yes, it's different. 2 minutes, and then we try to make it series, and this series video 1 until 6 we try to make it and in design and try to testing with expert. So the expert will try to make a correction and or evaluation. This is the sample of field trial testing, because this animation can be on smart television or in the notebook, and of course in the handphone or smartphone. Let me play this sample for one animation.
Ini kepala, tangan, dan kaki yang boleh disentuh. Itu pun karena mereka sayang padaku. Yang tetap baju dalam tak boleh disentuh. Hanya boleh jika perlu oleh ibu kandung. Yuk wahai teman, jagalah dirimu. Jangan sembarang orang boleh sentuh tubuhmu. Jaga bagian yang tertutup baju dalam. Jangan sampai terbuka dan dipandang setiap orang.
Okay, that's a sample for video number 3 about the self touch. The area or part of the body can be touched by self, or who can touch the body for this children episode 2. Okay, and then for the quantitative result that this research sample involve, this is for teacher, 136 teacher. After we try this video to the teacher for about 136 kindergarten teacher. The bifurcate analysis showed that there was an effect of teacher understanding of sexual education in early childhood on the attitudes of teacher in the implementation of early childhood sexual education. So for chi-square 27.227, the value 0.00. And number two, the results show for the teacher after watching this video will be there was an influence of teacher involvement kindergarten in training on teacher understanding of sexual education, chi-square 9.583, and effect of tenure of teacher on teacher understanding of sexual education and early childhood, the chi-square 13.575. The value 0.0. This effect, the effect is three effect about the understanding the sexual education and the tenor and the training on the teacher. And then this is for the parent. The parent, there's a mid-test and post-test before and after watching, and then we give them a questionnaire about the skill and for the parent, the increase from pre-test to the post-test. This is the quantitative result. So what is next, and what the part of an IT or computing research? Of course, our discipline is not just quantitative research, but we always research and development. So in the research and development, after designing and create the animation, our next stage of this research in our computing research, we developing the Mique and Miele animation series in a mobile application, which is can interactive with children and to the parent and the teacher to can use it as a tool for educate children. Of course, the application that we completed with augmented reality feature. Maybe yesterday, Mrs. Nora sorry about augmented reality research. That's the same, but we are in the field of this education, and we produce a book, and then we complete it with mobile app. This is the prototype. Oh, this is the design. So this use case design. Only one user, and then to watch video, and this video is 1, 2, 3, 4, 5, 6, and then the profile and this augmented reality and with button. And next, because I lecture in animation 2 technology, animation technology. So we upgrade the 2D to 3D. The 3D we create this from Blender. We create this with Blender, the free application. The Mique, the name is character is Mique and Miele, and created with 3D environment. And after that, we create mobile app complete with feature of augmented reality. And when we saw the book, when book have a marker, and we get this video on the 3D. This is the prototype of the something we create. So augmented reality in hands-on interactive action of real-world environment achieved through digital visual element, sound, and other sensory stimuli via holographic technology. So that's when the application create with Unity, and for the AR we create with health marker from Euphoria. Okay, our research publication can be read at this title, Developing Prototype of Mobile-Based Mique and Mila Animation Series Application with the Analysis, Design, Development, Implementation, and Evaluation Method. And then this is in Bahasa, the teacher contribution for the early childhood sexual education, and this is proceeding from seminar, international seminar, sexual education in early childhood through animation, and then the last, the use of internet mapping on parents of early children in industrial era 4.0. That our research publication about this today topic, sexual education for early childhood through animation series and mobile application. This is the, I think this is the abstract for each of this publication. And terima kasih. I think that's my lecture today. Thank you very much for your attention. Thank you.
Okay, so thank you so much, sir. Thank you so much, Professor Dewanto, for that very informative presentation about sexuality education in early childhood through animation series and mobile application.
Yeah.
Okay. So now we will entertain questions from our participants. Let me check the chat box. Okay. Probably to give time to our participants, sir, to type in their questions, please allow me to ask, sir, the first one, if that would be okay.
Okay.
Okay. What I want to ask, sir, is what are some of the key considerations that you had to keep in mind during the process of developing the animation series?
Okay. For the developing this animation series, of course, our research partner is master in this field in the counseling for early childhood. They know what the best series are on the starting point and point to educate for children, parents, and teacher. So I'm in the informatics section. For me, it's just combining and make it visual. So there's two character, boy and girl, and so we created character Mique and Mila. So it helped by our partner research. There's a master on this field. I think that's.
Okay, sir, thank you for that answer, sir, because I think the topic of the animation series, I think it's very creative, especially if you're going to apply it or incorporate the technology in it.
Yes.
Okay, very well said, sir. Let's go back to our chat box. We have questions. think we don't have any questions from our participants, sir. I think they understand your presentation very well, sir. So let us proceed to the next part, sir. Again, thank you, Professor Dewanto, for answering my
Thank you.
question. Yes,
Thank
sir.
you.
We appreciate your time and effort in sharing your knowledge with us, sir.
Thank you very
Okay,
much.
so
Nice to-
but before we move to the next lecturer, we would like to award you, sir, a certificate of appreciation. Okay, so let me just read the content, sir. So a certificate of appreciation is awarded to Professor Febrian Murti Dewanto for the invaluable service as speaker in the International Lecture Series in Computing Disciplines with the topic Sexuality Education in Early Childhood through Animation Series and Mobile Application at the Universitas PGRI Semarang in collaboration with the Don Mariano Marcos Memorial State University on April 13, 2023, given this day, 13th day of April 2023.
Thank you very
So
much.
yes, sir. Congratulations again, sir, and thank you for sharing your expertise with us. So now let's have a quick photo. I encourage all our participants to please turn on your cameras and give us your sweetest smiles on the count of 3. Okay, I will ask our technical team to take the screenshot. Okay, so on the count of 3, 1, 2, 3. Another 1, 2, 3. Okay, last one. 1, 2, 3. Okay, thank you, everyone. Thank you, sir.
Thank you. Thank you. See you.
Okay. So I think we still have time. Probably we can have a 5 minutes break before we proceed to the next lecturer. So please take this time to stretch and grab a drink. See you in 5 minutes. Okay, so welcome back. I hope everyone was able to freshen up a bit, and now we are. I hope everyone is now ready to listen to our second speaker. Okay, so again, before we start, please feel free to ask questions to our speakers with regards to their topics. Just type in your message or your question in our chat box, and I will be glad to read them during the question and answer on your behalf. Okay, so to proceed with our second speaker, we are honored to have Dr. Eusebio L. Mique Jr., who will speak about deep residual unit-based lung image segmentation for lung disease detection. Dr. Mique earned his Doctor of Information Technology degree from the University of Cordilleras in Baguio City. His dissertation investigated machine learning techniques for multiple classifications of lung diseases. Dr. Mique has been working as an instructor at Don Mariano Marcos Memorial State University since June 2013. He also has an extensive experience as a software consultant, programmer, system consultant, and IT faculty member at various institutions in the Philippines. Aside from his academic and professional achievements, Dr. Mique has also undergone specialized training programs in information technology and related fields from various organizations, such as the Association of Overseas Technical Scholarship. His certifications include ICT Proficiency Examination for Computer Programming and the Philippine National IT Standards, or the Japanese IT Standard. Dr. Mique has an impressive track record of published research in various international journals and conference proceedings. Some of his notable works include the development of a defense through deception network security model and the use of deep residual unit for lung disease detection. His research interests include machine learning, computer vision, and image processing. So please join me in welcoming Dr. Eusebio L. Mique Jr. Sir?
Thank you very much, Ma'am Krisha.
Yes,
Good afternoon to our participants. Salamat siyang to Sir Febrian and Ma'am Mega Novita, and to all our participants in Indonesia. Okay, allow me to share my screen. All right, so can you see my screen now? Can you see my presentation?
Yes, sir. Yes, sir. We can see your presentation.
All right, thank you very much. All right, instead of discussing my paper, which is entitled Deep Residual Lung Image Segmentation for Lung Disease Detection, I will just be discussing the technology that I used in that paper. So that paper actually was presented in Indonesia way back 2019. Anyway, I'll be discussing the technology behind it, which is the deep residual unit image segmentation. Okay, for this day, for this lecture or this sharing, I will be discussing a bit of image segmentation, deep learning, and I'll try to differentiate also the unit and the deep residual unit, which I use both in my paper. Then I will also be discussing some performance metrics for image segmentation. Okay. So first of all, let me define image segmentation the best that I could. Okay, image segmentation is a technique that we use for computer vision or image processing to partition an image into multiple parts or regions, often based on the characteristics of the pixels in the image. So in short, image segmentation is just separating the region of interest to the background of that image. So what are the different applications that we can that image segmentation can be used? So one is object detection, also image editing, medical or biomedical imaging, and autonomous driving. And there are also different approaches in image segmentation. There are thresholding, clustering, region growing, edge detection, but I will be focusing on the deep learning, which the deep residual belongs to. Okay? But anyway, I'll be giving a short background on the different approaches as well. Let's start with thresholding. All right. Okay. So thresholding involves dividing the image into two or more regions based on the threshold value. The value is usually chosen based on the intensity of the pixels in the image. And pixels that fall below or above that threshold are assigned to different regions. So the first thing that we do in thresholding is to set our criterion. One criterion is to identify or the threshold, the value of our threshold. Then from that threshold, anything that goes beyond or goes below that threshold will fall to the different regions. So thresholding is effective when the region of interest or our ROI have well-defined boundaries and there is a clear difference in the intensity values between the objects and our background. So there are different types such as global thresholding. The global thresholding involves selecting a single value for the entire image. And this is applied to all the pixels uniformly. Okay, usually we use the Otso's method or the triangle method for determining the threshold. The aim is to find the threshold value that maximizes the separation between our foreground and the background of the image. So we have an example here for global thresholding. Another one is local thresholding, or sometimes referred to as adaptive thresholding, which involves selecting a different threshold values for different regions. Adaptive thresholding can be implemented using the techniques such as mean thresholding, median thresholding, or using Savola's method. Okay, so we try to find the difference between the ROI based on the local characteristics of the image, such as the contrast and the brightness. Okay, so we have an example here. This one set for the different threshold, and it provides different results for our thresholds. Okay, next we have clustering. I'll just be giving a short background on the different approaches, and then later on we will be dealing with the deep learning part, and we will be presenting the unit and deep residual unit. Okay, let's now proceed to clustering. This one involves grouping pixels with similar properties into regions or clusters. These are used to identify objects or regions of interest or our ROI in the image based on the similarity of the object. So we are taking into consideration color or the texture of the image. So this clustering approach is effective when our area of interest have the same properties or similar properties that distinguish our ROI from the background. Okay, one popular clustering algorithm is the k-means clustering. This one defines the number of clusters, and it will be divided according to the different clusters that we set. So example of this, we have an image which looks like this one, and applying k-means will give us this result. Right, and we also have an image for the dog, and will give us this output using k-means clustering. Another approach is the region growing. This one segment or a segmentation technique based on the similarity of the neighboring pixels. So we have to identify or set the seed pixel as we call it. That's the starting point, and we have to check or check the similarity between our seed to that of the neighboring pixel or the adjacent pixel. And if that is similar to that seed pixel, then it will be added to that region. Region growing is effective for image segmentation when the region of interest or our ROI have well-defined boundaries, and there is a clear difference between the intensity values between our objects to that of the background. This is also effective for irregular shapes or boundaries as long as we have set our similarity criteria. Okay. Example for region growing is this one. So we have set our seed pixel, and from that checks the different pixel from its neighbors. And if that belongs to the same characteristics, then they will be included in the region. It grows until the boundary is reached or there's no more similar pixels that can be attached to the region. Another one is what we call as the edge detection. Edge detection is the process of identifying the boundaries between different regions in an image. So we have to identify the pixels in an image that corresponds to our object boundaries and distinguish from the pixels that corresponds to the background. The common algorithm that we use for this technique is Sobel, Canny edge detector, and we also have the application of Gaussian operator. Some example for Canny edge detection. This image here, applying Canny edge detection will give us this one. There are two Canny edge detection used here. And next is the deep learning, which our focus for this sharing. Deep learning is a subset of machine learning, which uses artificial neural network to model and solve complex problems. This deep learning is highly successful in image segmentation tasks, especially with the use of convolutional neural networks. Okay, some deep learning architectures that we can use for segmentation. We have FCN, or the fully convolutional neural network. We have the UNet, Mask RCNN, and DeepLab. So later on, we will be talking about the UNet architecture. The only drawback with deep learning is that it requires large amount of data and significant computational resources to train the model. So for some application, this technique is expensive, right? Let's go now to the UNet. All right, so we have the UNet convolutional network. UNet is a popular deep learning architecture for semantic segmentation. So later on, we will be talking about semantic segmentation. This unit was developed by Olaf Ronberger in 2015 for medical image segmentation task. So this is a convolutional neural network for biomedical imaging. It has gained popularity due to its ability to segment images with small number of training samples. Deep learning, as we have mentioned a while ago, that it uses large amount of samples or data in order to create an accurate model. But with the unit, they have proven that with just a very few samples, we can also produce high accuracy model by just augmenting those images. So for unit, if you have a few samples, this is very good for that particular data set or for that particular modeling that we will be doing. So for let's discuss semantic segmentation because unit uses semantic segmentation. For semantic segmentation, this categorizes the pixel, each of the pixel in the image into a certain class or object. So it associates those pixels in our image, just like our picture here. So we have classes such as person or people, and classes such as cars, the pedestrian, the signboards, trees, the sky, building, etc. So semantic segmentation is also considered as an image classification task at pixel level, as involves differentiating between the objects or the different objects in our image. Another extension of semantic segmentation is what we call as instance segmentation. This is different from semantic because this one delineates each distinct instance of the object rather than grouping into a single class. Let's say the cars here. These are already grouped as an instance of the car object. Another example. Okay, let's have the input image as the table and the chairs. If you notice in semantic segmentation, all the chairs are classified as chair. But in the instance segmentation, it created an instance of those chairs. So created how many instances of the chair in this instance segmentation. Another one. Another object here. There are 5 persons. Then we have semantic segmentation classified as a single class, but in instance segmentation, it tries to instantiate each of the object found in the input image. All right, so we now proceed to the unit architecture. So this one was used in our paper, in one of the paper. So the unit architecture is composed of different layers. We have the U shape. That's why the term unit was used for this architecture. Now, before we discuss the architecture, let me discuss some of the terms that we will be using here. We have the convolution, pooling layer, and the activation layer. Okay, so I'll try to discuss convolutional layer, our kernel, our pooling layer, and activation layer. So what is a convolutional layer? Convolutional layer is simply performs the operation called convolution. So what is this convolution? It's just multiplication of our input image with that of the weights. Okay, so just like what we see in the animation, it tries to multiply our weights or our kernel to that of the image, and then creates a convolved feature or our feature map. This feature map, by the way, is used or created by sliding our filter, our kernel here, over the input image so that we can have a feature or recognized patterns in the image. Okay, so how it is done? The convolved feature is simply the sum of the product of the matrix multiplication. Later on, I will discuss this. Next is the kernel. The kernel is our matrix of weights applied to the input during convolution operation, just like this I discussed in the previous slide. Kernel is sometimes referred to as our feature extractors or our filter. So this one detects features or patterns in the input such as edges, corners, and texture. So given our kernel, a 2x2 kernel, it will be multiplied to our input. So it will take first the first 2x2 in our input, multiply that, get the sum, and that will be form part of our output. Example here, we have 0 times 0 plus 1 times 0, and 0 times 2 plus 3 times 0. So the result will be 0. And then we slide. Normally this slide or the stride is 1. So we move 1 pixel to the right. So again, we will create a 2x2 matrix from our input and multiply that to our kernel. So that's how our convolution works, by multiplying our weights or our kernel to the input. All right, next we have the pooling layer. Pooling layer or downsampling, or reducing the size of our feature map. So pooling layer downsample our feature map to introduce what we call as the translation invariance. So this one reduces the overfitting of our CNN, overfitting or overtraining of our CNN model. So what is this translation invariance? If we have a feature map, the feature map are location dependent. Meaning if we shift our image or our object, it will no longer be recognized by our model. But using pooling layer, this feature map will be invariant to translation, meaning even if we move or shift the image, our model can still recognize the features in that input. Okay. So the purpose of pooling is to gradually shrink our feature map into smaller spatial dimension to minimize the number of parameters and computations in them. There are two types that we can use for our pooling. We have max pooling and average pooling. So max pooling will make our feature map sharper, while the average pooling will smoothen or soften our image. Okay, there are drawbacks in the two types of pooling. The first one, for max pooling, if we have a high intensity background, max pooling is not recommended. Why? If we have something like this image here, if we apply max pooling, it will give us pure white result. So that is getting the maximum. Let's say we have 255 here, this one, this area here, and 255 for this area here. So getting the maximum with this region, 2 by 2 region, will give us the maximum, which is 255. Same thing on the other regions here, 255, all 255. So that will give us all 255, and everything will be 255. So everything will be white in our result, in our feature map, or in our downsample feature. For this application for white background, it's better to use average pooling. Now, for black background or dark background, better to use max pooling. Okay, as we can see in our results set here. So we have 255 here, this one, 255 and 255. So the result will be 255. And since this is 0, 0, so this will give us 0 here. So it will produce this result. It will give us a more accurate result if we have a black background or dark background for max pooling. All right. The next algorithm is what we call as the next layer is the activation. The most widely used activation is what we call as the ReLU, or the rectified linear unit. This one converts all negative values to 0 and the positive as it is. And we use also sigmoid for unit, uses both the ReLU and sigmoid. The sigmoid is for the final layer or final fully connected layer. This will produce, this is used for actually for binary classification. So it will produce, the range will be from 0 up to 1. So that's for our activation. Now, summarize, we have our input image. Our input image, now using our learnable kernel, we will slide our kernel, our 3 by 3 or 2 by 2 matrix, depending on what you set in your kernel, will be slide over the image, our input image, and it will create a feature map. And using max pooling, will reduce the size or our spatial dimension into this size for our feature map. That's the use of the pooling function. So the learnable kernel will produce our feature map. When we say feature map, these are the important characteristics taken from the input image. Okay. Now let's go back to our architecture. So the architecture is composed or divided into 2 parts. The first part is our contraction part, or our encoder. The encoder is composed of 4 blocks, which is composed of 2 convolutional layers for each block. And we also have the bottleneck and our expansion or expanding part, or the decoder part. All right. Now in the encoding part, this takes the object. Okay, this focuses on the what, or the object itself. The problem with this is it will not identify the location or the where of the image. That is why they have created a skip connection. The skip connection will allow localization by concatenating our the last layer to our output or to our decoder. It will produce the localization information. Okay, so that's the use of the skip connection. So we have the encoder, the decoder, and the skip connection. These are the important feature of our unit architecture. Okay. By the way, the unit architecture can be modified. You can modify some parameters here, just like the size. Initially, we use here a channel of 1. That means the input is a grayscale. And the first layer or our feature map is a 64 filter feature map. And downsampling that will create a 1:8 feature map, and so on and so forth. And in our expanding or in our decoder, we use what we call as the transpose convolution. So that's the upsampling. So in the encoder, we try to reduce the size of the image, but in the decoding part, we try to get back to the size, or to get the original size of our image, so that in our last convolution will form or will give us the image or the segmented image. Plus, of course, with the concatenation will give us the localization, where the actual image is located. Right? Summarize our unit architecture. So one of the main feature of our architecture is the use of encoder and the decoder. First, the encoder receives the image or our input image, extracts useful features from that image using multiple convolutional layers. And then next, the decoder will upsample or transpose convolution the feature using transpose convolution and concatenate with that of the skip connection. Okay, so the result will give us a segmented mask of our input image. So one important feature of skip for unit architecture is the skip connection. The skip connection will allow us to skip some layers from our input and feed that to our output layer. So with the help of this skip connection, we will be able to achieve better segmentation. All right, so that's unit architecture. Now let me go to deep residual unit architecture. If you notice, in our deep residual, it's almost similar to that of the unit. But this time, we have added, or they have added additional layer or convolutional layer or blocks to this deep residual unit. Deep residual unit architecture is also known as the REST unit. It was developed by Zhang Zhen for semantic segmentation. Initially, it was used for road extraction or high-resolution aerial images in the field of remote sensing image analysis. Okay, so let's try to break down the different parts of our REST unit. So the idea behind deep residual unit is that we have a residual block which is composed of 2 convolutional layers plus batch normalization and activation layer. The second convolution or the second convolutional layer is added to the input as input to the next layer, directly added to the input to the next layer. Okay. Notice here that we don't use pooling layer. Instead, we use batch normalization or the BN. You notice the BN here or batch normalization. Batch normalization is actually a technique used in deep learning or in our neural networks to improve training performance. This reduces the number of epochs required or steps required to train our model. So it works by normalizing our inputs to each of our layer, making it easier for the model to learn the weights and biases. Okay. All right, let's differentiate the two. In unit, we have convolutional layers composed of a convolution with a 3x3 kernel. Then we have ReLU or the activation unit, rectified linear unit, and another convolution and another activation. But for deep ResNet, notice here that the residual block contains what we call as identity mapping. The identity mapping is similar to our shortcut connection or our skip connection in the REST unit or in the unit architecture. So this allows the network to learn residual functions, which are difference between the difference between the input and the output of the shortcut connection. So how these things work? So the input to the previous layer is added to the residual block. Then we apply batch normalization and activation layer. Then we perform a 3x3 convolution. Then another batch normalization and activation. Then the convolution or the next convolution is added to the input map, or the result is added to the input of the previous layer. Okay, so that's how the REST unit is differs from the unit architecture. Now let's try to show some codes, sample code in Python, Keras. Okay, so this one defines our batch normalization, our BN, which is simply taking the input, normalize it using batch normalization function, and the output, the result, will be used for activation using ReLU. So we return our activation or normalized and activated unit. By the way, what is ReLU or what is activation function? This activation function will give us the fired neurons that will be entered to the next layer. Okay. Next one, we have the residual block. If you notice here we have the residual block, which is composed of the batch normalization. So the input is normalized. The result of this batch normalization will be our input to the convolution function. So we have to identify how many filters we will use for this convolution. Normally, the encoder part will be increasing and the decoder part will be decreasing. Okay, and using 3x3 filter, and we have a padding as same. What is this padding? The padding is used to preserve the edges of our image when we apply our convolution. Okay. So we have batch normalization, another batch normalization, and another convolution. And take note, the third convolution here will make use of the input instead of the output of the previous convolution, meaning it will directly get from our input from the previous layer. And then we add that, we add our X, or the output of our convolution plus batch normalization, plus the output of our last convolution. So we return the value of the addition of the previous, or the X, which is the value of our batch normalization and convolution. And the S, which is the convolution, the last convolutional layer. And then we have the decoder block. So the decoder block is simply upsampling. So in the upsampling, we use transpose convolution. Okay. This time we use or make use of 2x2 filter to our input. Then we concatenate our skip feature. Notice our skip feature earlier. Let me go back to that. This one, the skip from our input. Concatenate that. And then we make use again of, or we call again the residual block, taking our filter or our input and the number of filters plus our stride. So stride here is the number of steps from our input. And here is the building block of our REST unit. So we have the encoder part, our first encoder, which is simply convolution. If you notice here, there are 64 filters that we use for our first encoder. Notice that this will increase to 128 and 256 for our three encoders. So the first encoder will be applying convolutional layer with 64 and 3x3 kernel with a stride of 1. And then for the next encoder, which now uses our residual block. So this one is also a residual block, but since in the function residual or our residual function, we make use, we first applied batch normalization. In the case of the first encoder, we don't use batch normalization because we have not yet applied convolution to our input. So it's just the same, but with the additional convolution layer in the first encoder. But in the succeeding encoder or residual blocks, we just call our residual block. Okay, taking into the residual block, our input as the output of the next or of the previous encoder. Okay, that's our encoder. And for our decoder, by the way, we have a bridge. The residual block, it's still a residual block for our bridge. And then we have the decoder, which upsamples our image. If you notice, it now decreases into 256 features or feature maps or filters, 128, 64, and the classifier using sigmoid, which will give us now only 2 output. So convolution is 1 by 1, the padding is the same. So this will give us our REST unit model. Okay, so how did I use this REST unit in my research? Now, my study is about lung disease detection. In order for me to accurately and improve the performance of my model, instead of training the entire X-ray image, I use lung segmentation or deep unit or REST unit to segment our X-ray image, taking only our region of interest, which are the lungs. Okay, so using REST unit, I was able to achieve a very high accuracy in my result set. But first, during the training for lung segmentation, I have to look for manually segmented or manually masked X-ray images. So if you cannot find manually masked images, fortunately I was able to find one. You have to manually mask it yourself. So manually masking meaning you have to create a mask of our lungs, of these lungs, for all your X-ray samples, and then feed that to your depth press unit or residual unit and train your model. And here are some of the results that I have captured from my research. So I have here the actual X-ray, and it produces this mask of the X-ray image or the chest X-ray image. Additional result. So I have compared actually the predicted result to that of the ground truth. The ground truth are the manually masked images, lung images. Then I have input the X-ray, and my model was able to produce these predicted results. So it's almost similar to that of the ground truth. Okay. So these are the sum of the output of my research. And the last that I want to discuss is the evaluation metrics that we can use to evaluate semantic segmentation. Okay, there are three that I have presented here, but I highlighted only one, the dice coefficient or the F1 score. For pixel accuracy, although when you apply these metrics to your output for your model, it will produce a high accuracy rate because of it will just check the pixels, but it will not identify the location of that pixels if they're correct. So it will produce, but if you look at on the mask, the ground truth and your predicted result, it will not match even if you have a very high accuracy pixel result. We also have the Jacquard index or the intersection over union. This is almost similar to the dice coefficient. So this is the area of the overlap between the predicted segmentation and the ground truth divided by the area of union between the predicted segmentation and the ground truth. The dice coefficient, which I have used in my study, is using the formula twice the area of the intersection of your A and B, or your predicted and the ground truth, divided by the sum of the area of A and B. So this is different from the F1 score that we use for classification, because in classification, we only have to match the value, but in dice coefficient, we have to also match the value plus the position of the object. Okay, so if you are interested in this particular topic, maybe you can send me an email, and I will be providing you some samples with regard to the use of deep residual and unit, as well as the dice coefficient. So thank you very much for listening. Terima kasih, and maraming salamat to all our participants. Back to you, Ma'am Fisha.
Okay, thank you so much, sir. Thank you, Sir Mique, for that very insightful presentation. Okay, so now we will open the floor for questions. Okay, but I think for the benefit of everyone, will it be okay, sir, if I ask the first question?
Yes, ma'am. Go ahead.
Okay, just while waiting for the participants to type in their queries, sir. Sir, with regards, sir, to your paper or the research about image segmentation or the lung segmentation, sir, guess it's quite interesting, sir, to learn about the image segmentation. Can you speak more about the limitations, sir, and the challenges that you have encountered during the development of the model?
Hold on. Okay. Sorry for that interruption.
It's okay.
All right. Actually, I have used different architecture during my study. I have used UNet. Actually, the first architecture that I used was convolutional neural network, and then I was not happy with the result. I tried UNet, and actually the result for UNet is already acceptable because the result is almost 90%. And actually, I published a paper for UNet lung segmentation, and I tried the deep residual. Because in the UNet, as I have mentioned in my presentation, you can change the parameters. While changing the parameter, it improves the result. So I tried. I have read this paper about deep residual UNet, which they combine the power of UNet and that of the residual connection. When I tried that, it improves my segmentation task. So the accuracy improves. That's why when I trained for my other paper, which is lung disease detection, I use the segmented as the input instead of the X-ray images. So there are many challenges actually. I've tried different models also for my training for the training of my model for lung disease detection. I have tried transfer learning. I've tried different approaches. I've used the BG-G16 and other transfer learning architecture. But I ended up using my own architecture for the lung disease detection, which is not discussed in this presentation.
Okay, so thank you so much, sir, for answering my question. I think your answer, sir, will be very helpful to our students who are with us today, just in case they are interested in the same topic, sir.
Yes, ma'am. I'll just be sharing my email, and if somebody needs additional information regarding image segmentation or any topic on machine learning, specifically image processing.
Okay, just to give them also the idea of what might be, what to expect, or what might be the challenges also that they may encounter. Okay, so
yes, ma'am. One of the challenges is for our data set, looking for data set for a certain topic. Let's say, fortunately, in my case, I have downloaded. There are plenty of resources that where I can where I got that data set. So there are different topics that just like pest detection in rice. Normally, we don't have enough data set for that, so they have to manually create their own data set. So that's the challenge actually for image processing or computer vision.
Sir, well said, sir. Thank you so much for your answer. Going back to our chat box, still we don't have any question. I think you have presented your topic, sir. That they were able to understand it very well, sir. Okay, so since there are no questions, let us proceed to the next part. By the way, sir, thank you again. It is truly a pleasure to have you as our speaker today. So now I would like to ask our technical team to present the certificate. Okay. So a certificate of appreciation is awarded to Dr. Eusebio L. Mique Jr. for the invaluable service as speaker in the International Lecture Series in Computing Disciplines with the topic Deep Residual Unit-Based Lung Image Segmentation for Lung Disease Detection at the Universitas PGRI Semarang in collaboration with the Don Mariano Marcos Memorial State University on April 11, 2023, given this 13th day of April 2023.
Thank you very much.
Yes, sir. Congratulations again, Sir Mique, and thank you for sharing your expertise with us. Again, let us have a quick photo op with our participants. So to all the participants, kindly once again, please turn on your cameras. And on the count of 3, please give us your sweetest smiles. 1, 2, 3. Okay. Another. 1, 2, 3. Last one. 1, 2, 3. Okay. Also to our participants, the link for the attendance list for today's session is already in the chat box. So I think we have reached the end of the webinar session. Again, thank you to our speakers for today, Dr. Dewanto and Dr. Mique. So on behalf of the organizers, we would like to thank all our participants for joining us, especially to the technical team for their assistance, and of course, to all the participants we have here. Please join us again tomorrow for another exciting lecture series. By the way, Dr. Novita, are you still here? Is Dr. Novita still here? Okay. Okay. I think that's it for today. So please join us again tomorrow, and I wish everyone a great day. I hope to see you tomorrow, everyone. Bye-bye.
Thank you.
Thank you.
Thank you, sir.